If you're in the business of creating objects, anything from rings to rocket parts, a prototype is likely to be an important step in your design process. Traditionally, prototyping involves creating a model or a mock-up of the product, turning it from a drawing into a 3D dimensional object to get a sense of what it would look like once made. Carved from wood or foam or built from clay or cardboard, these models can take a long time to craft and usually don't have all the qualities of the real end product. They can be helpful for demonstrating a new product's idea, but not always for testing its function or structure. Rapid prototyping using 3D printing has completely changed the game. Using this technology, you can make prototypes quickly, cheaply, and with more functionality than the traditional methods. It allows you to test and refine your design easily and can help you get your product to market faster, possibly before the competition. So how does it all work? Like traditional prototyping, the process starts with a drawing. Most design teams will use CAD, a software for this stage. CAD stands for Computer Aided Design, and CAD software allows designers to create precise 2D and 3D drawings, much more quickly than the manual drafting methods. A lot of troubleshooting and design refinements can be done at the CAD stage, but 3D printing takes things to a whole new level. Using a CAD file as its digital input, a 3D printer, also known as an additive manufacturing machine, will replicate the design layer by layer. Fused Deposition Modelling, or FDM printers, do this by melting a thermoplastic thread. They're useful for cheaply producing very basic proof-of-concept models or for simple shapes or parts. Some FDM printers use carbon fibre or metal-infused plastic threads to create stronger, more detailed design. Stereolithography, or SLL printers, use a laser to cure liquid resin into hardened plastic and can create very detailed designs with a smooth finish. Different resins can be used to mimic the properties of different materials. Selective laser sintering, or SLS printers, use lasers to fuse small particles of polymer powder, often nylon. They're good for complex shapes and functional parts, but the finish is rougher than you'd get from an SLA printer. Metal 3D printers are obviously the go for accurately prototyping metal objects. It's a more expensive process than plastic 3D printing, but still far cheaper than the traditional metal casting or machining. Some printers can even combine different materials as they print. The machines themselves are relatively easy to use, whereas traditional model making often requires a specialist skill or equipment. And because they work differently from the CAD files, you know the prototype you get is exactly as it was designed, ready to show to investors or focus groups. If the prototype reveals a flaw in the way of the product looks, feels, or works, then adjustments can be made in the CAD file and a new prototype produced. The process can be repeated until the product is considered ready to manufacture. While having access to a 3D printer in-house is convenient, there are also businesses that will print your prototype for you almost as quickly. So weigh up the costs and benefits before investing in your own equipment. Prototyping using 3D printing can be valuable to any business that wants to mass produce 3D objects. Jewellery, consumer electronics, furniture, automotive, and aerospace parts, medical devices, and more can be modelled and tested using this technology. It can help to get your product right, which is good for your customers, sales, and brand. And it can avoid having to change your design or manufacturing setup during production, which could cost you money, time, and market opportunities.